We're going to do question 2, and we're given this quadratic sequence of 321, 290, 261, and 234. So the sequence continues. In 2.1.1, we are asked to write down the next two terms of the sequence. So what we're going to do is you have 321, 290, 261, 234. So to write down the next two terms, we're just going to find the first difference of the sequence, which is minus 31, minus 29, minus 27, and we find the second difference being 2, right? So we know just the first difference is 290 minus 321, just like that, 261 minus 290 to get the first difference, and then the second difference, we just subtract these two here. So it's saying minus 229 minus 31 to get the second difference, right? So to find the next terms, the next two terms, so because the second difference is 2, it means now this sequence is increasing. Remember, it's negative 31, it's smaller, and this negative 27 is larger. So this sequence is increasing by 2, right? By a constant difference of 2. So meaning that here it's going to be minus 25, and then here it's going to be minus 23, right? So as it decreases, what we're going to do is we're going to say this 234, we're going to add it with this minus 25, and then we get our following sequence, which will be 209, and then we do the same thing. We say this 209 plus this minus 23, we're going to get 186. So these are our next two terms of the sequence. Now 2.1.2, we are asked to find the general term of the sequence in the form of Tn is equals to an squared plus bn plus c. So to find the general term, we are having our sequence, or our quadratic sequence rather, being 321, 290, 261, 234, 209, and 186, right? So we're going to first find the first difference of the sequence, right? So the first difference, we have minus 31, minus 29, minus 27, minus 25, and minus 23, right? So, and then the second difference of the sequence is going to be 2, right? So it's 2, 2, 2. So to find the value of a, so we're going to say 2a is equals to 2, which is the the second difference rather, this second difference. And let me just label this as the first difference. So to find the value of a, we're going to divide by 2 both sides. So our a value is equals to 1, right? And then our going to use the first difference, so it's going to be say 3a, and then we're going to use our first difference, so we're going to say 3a plus b is equals to our first term of our first difference, which is minus 31, and we know that a is equals to 1, so a into 1 plus b is equals to minus 31, right? So you're going to transpose this to the other side and find your value of b, so which you'll find b being equals to minus 34, right? And then to find the value of c, we're going to say, so let me remove this, we're going to say a plus b plus c is equals to the first term of your sequence, your quadratic sequence, which is this one, 3, 2, 1, and our value of a is equals to 1. Our value of b is minus 34 plus c is equals to 3, 2, 1. You're going to add everything up, and your c value is supposed to be 354, right? So you have your value of a, b, and c now. So you'll be able to identify the formula. So Tn is equals to an squared plus bn plus c, right? And our value of a we found to be 1, so it's going to be n squared. And our value of b, it's minus 34, so it's minus 34n. And our value of c is equals to plus 354. So this is our general term of the sequence. 2.1.3, which terms of the sequence will have a value of 74? So we're going to use our Tn. So Tn is equals to n squared minus 34n plus 354, right? So which term is equal to 74? So it's 74. So it's going to be 74 equals to n squared minus 34n plus 354. So we're going to transpose the 74 to the other side. We have n squared minus 34n plus 354 minus 74 equals to 0. So we have n squared minus 34n plus 280 being equals to 0. So to find the value of n, we can use our quadratic formula, which is n being equals to minus b plus or minus the root of b squared minus 4ac divided by 2a. And we're going to substitute into our quadratic formula. So n is equals to minus our b value, it's minus 34, plus or minus the root of minus 34 squared minus 4. Our a value is 1, our c is 280. And then we divide by 2 into 1. So our n is supposed to be 20, or n is supposed to be 14. So remember, we are asked to find the value of n such that the general term was equals to 74. So these two n values are applicable since we were asked to find the number of term, open bracket s, which is terms. So yes, this is the final answer for this question here. 2.1.4, which term in the sequence has the least value? So we want to identify the term. So I'll first draw a diagram. So this is our Cartesian plane. Normally in a Cartesian plane, the x-axis has the x values, right? In this case, it's going to be n, right? Because our formula Tn is equals to an squared plus bn plus c, right? So why am I doing this? You must take note that the quadratic number pattern is actually a parabola, right? So n squared minus 34n plus 354 is the formula that we got, right? And you can see that this is actually the standard form of a quadratic number, a quadratic graph, right? Or should we say a parabola, right? So for us to be able to represent this equation here, we know, as I wrote here, it's n, meaning that these n values here are representing the x-axis, and the Tn represents the y-axis, right? So it's going to be Tn there, and then let's say I draw a parabola that looks like this, right? And we want to identify the n value that gives us the least value. So when you talk about the least value, we're going to look at Tn in this case, but normally you'll be looking at your y values. But since our y-axis is Tn, so we want to find which point does this parabola have the least value of Tn. It's at the turning point, right? At the turning point, you have the least or the smallest value of your y, because you're used to the y-axis, right? Your y values, which in this case the Tn. So if we were to write the turning point, it's going to be n and Tn, right? So I want to find the smallest value of Tn. The smallest value of Tn happens here, but for us to identify the term when the smallest value of Tn is at the turning point, we need to use this formula of x being equals to minus b over 2a, right? Because we are looking for the term and not necessarily the least value. If we're looking for the least value, we're going to use this x being equals to minus b over 2a and substitute it in the Tn formula to find the least value, the specific Tn value, which is the smallest value of this parabola, right? But we are looking for the number of terms, the n term, this n value here, the number of the term which gives us the smallest value. Sometimes they can say the minimum value, right? It gives us the minimum value of the sequence, right? In this case, we are looking at the equation here. So to find the minimum, or the term rather, which gives us the minimum value, we're going to say, so it's going to be n is equals to minus b over 2a, which is equals to, so our b is equals to minus 34. So it's minus 34, which I took from the equation, and our a value is equals to 1. So you're just going to substitute that minus into minus 34 divided by 2 into 1, right? So you'll find that your n value is equals to 17. So this is the n value which will give you Tn, which is the smallest, which will give you the smallest Tn value of the function. Going to 2.2, we are given this geometric series here of 5 over 8 plus 5 over 16 plus 5 over 32 plus going up until it gives us a sum of k. So this is the sum, Sn, which is equals to k, right? So 2.2.1 says that determine the value of k if the series has 21 terms. So you know that the sum is equals to k, right? So we're just going to use the geometric series equation to find the specific value of k. So we know very well that the sequence, let me just write the sequence. The sequence is this one here, right? 5 over 8, 5 over 16, and 5 over 32. So it's going to be 5 over 8 plus 5 over 16 plus 5 over 32 being equals to k, right? And we're going to find our value of r. So if this is, let me do this. This is term number 1, term number 2, and term number 3. So our value of r, because this is a geometric series, so it's going to be t2 over t1 equals to t3 over t2, right? So term number 2 is equals to 5 over 16. Then we divide by term number 1, which is 5 over 8, equals to term number 3, which is 5 over 32. Then we divide by 5 over 16, right? So your r value that you need to get is 1 over 2, right? So now we're having our r value and we're having our a value being equals to 5 over 8. We can simply find the sum of the sequence and equate it to this k, because k is actually Sn. So the geometric series equation of the sum is Sn being equals to a into 1 minus r to the power n divided by 1 minus r, right? And Sn is equals to k being equals to a, which is our first term is this one here, which is 5 over 8. So we're just going to write 5 over 8 into 1 minus our r, it's 1 over 2 to the power of 21 terms, right? And then divide by 1 minus into 1 over 2. So what you're going to do, because we are looking for the value of k, so you can simply punch this whole expression here in your calculator if possible, or you can just simplify it further. But I did punch everything out in my calculator and I got the answer of 1.25. So this is my value of k. 2.2.2 says that determine the largest value of n if we're having Tn being greater than 5/8,192, right? So what we have here is this, we want to identify the largest value of n, right? When Tn is greater than 5/8,192, right? So we're still going to use the geometric series, which we know our a value being 5/8 and our r value being 1/2, right? So Tn of a geometric series is Tn is equals to a r to the power n minus 1. In this case, to find Tn, our a value is going to be 5/8, and then r is 1/2 to the power of n minus 1, right? So we are looking for the n. So we can simply substitute this Tn here, which is this one, into here, right? Just here at Tn. So we're just going to do that. So meaning we're just going to say, since Tn is greater than 5/8,192, so we're just going to write this here, which would be 5/8 into 1/2 to the power of n minus 1 greater than 5/8,192, right? So what we're going to do is we can remove this 5/8 by dividing it out. So we'll remain with 1/2 to the power of n minus 1 greater than, so we're going to have 5/8,192 divided by 5/8, right? And you will get 1/2 to the power of n minus 1 being greater than 1/1024, right? And then because we're looking for the value of n, so we can make the base the same. So it's 1/2 to the power of n minus 1 greater than 1/2 to the power of 10, right? So the bases are the same. It's 1/2, 1/2. So you drop the exponent. So it's n minus 1 being greater than 10. And then you transpose the -1 to the other side. We have n being greater than 10 plus 1. So it's n greater than 11. So to find the conclusion of the value of n here, you need to substitute your values of n. So what you're going to do is this, because you'll be having this part here, I'm just going to shade this part, you'll be having this part here, and we are told that Tn must be greater than 5/8,192, right? So you're going to substitute your value of n here. Now that we found n being greater than 11, right? We found n greater than 11. So you're going to substitute n being equals to 12 and see if you're going to get a value that is greater than your 5/8,192. But if you don't, then which means if it becomes smaller, then which means you need to use an n value that is less than 11, right? Which is what I found when I was solving this problem here. Found that as you go up, if you say you use 12, it doesn't give you Tn being greater than 5/8,192, right? So what I did was I used a smaller value of n, right? So instead of going up to 12 or 13, just go less than 11, right? So you can test 11 and see if it's going to give you Tn of greater than this 5/8,192, right? And the conclusion that I found when I was testing everything is that if you use n equals to 10, it definitely gives you Tn being greater than 5/8,192. So the answer that you're going to get is definitely going to be greater than 5/8,192. So n being equals to 11 is the final answer of this problem here. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.